This is the first part for the topic of series, and we're going to look at binomial expansion. Now, before that, we need to know what this is. Combinations of R objects from N objects. What does that mean? So if you have N number of objects, and you want to choose R objects from there. You want to choose them. Suppose you want to choose 3 objects from there. Then, how many ways can you choose them in? And that's what this is. N choose R will give you the number of ways you can choose 3 objects from a group of 6 in this case. And you do use these in stats when you do it in second year or when you do it in first year, whenever you're doing it, right? Now, the way we write this is this vector where the top one is N, the bottom one is R, or we can write it as NCR. I like this better because it reminds me N choose R. Now, what exactly is the formula? You take the number at the top, yeah, and you take the factorial of it. What does factorial mean? Suppose the factorial of 5, that is just 5 times 4 times 3 times 2 times 1. And so you'll take the factorial of N, where it's N times N minus 1 times N minus 2, and we go on up to we get 1, right? And then we would divide it by R factorial, so the bottom number is factorial, multiplied by the top minus the bottom number is factorial. So R factorial times N minus R factorial. So R times R minus 1 all up to times 1. And then we have N minus R, N minus R minus 1, and we'll go on up to 1 as well. And then we usually will be able to simplify because obviously if we have 5 factorial, and if we divide it by a factorial that's smaller than that, suppose 3 factorial, remember 5 factorial is just 5 times 4 times 3 times 2 times 1, while 3 factorial is just 3 times 2 times 1. So we will be able to cancel out the last part of the 5 factorial. And that's how it works for all divisions of factorials. For example, this 7 choose 3, which will be 7 factorial over 3 factorial times 4 factorial. Why 4? Because 7 minus 3 is 4. Then we will get this nice cancellation right here. And we'll be left with 7 times 6 times 5 over 3 times 2 times 1. So we cancel 4 factorial from the top. Then here what we can do is we can cancel it again. 6 is just 3 times 2, right? So we end up with 7 times 5, which is 35. Let's do the following with our calculator. So remember, you can cancel out by the bigger factorial, right? So 7 factorial, we divided it by 4 factorial, and the whole 4 factorial will cancel out from the 7 factorial, right? So here even, if we take 10 factorial and we divide it by 8 factorial times 2 factorial, why times 2 factorial? Because we do 10 minus 8 as well. We will get just 10 factorial, which has 10 times 9 times 8 times 7 times 6. So we have 10 times 9 times 8 factorial, and you want to divide it by 8 factorial times 2 factorial. What this does is you can cancel out the 8 factorial part. We'll be left with 10 times 9, which is 90, divided by 2 factorial, which is just 2 times 1, which is 2. So 10 times 9 divided by 2, which is just going to be 45. Okay? Then 40 factorial divided by 38 factorial, again, same thing. The 40 times 39 remains. 38 factorial at the top will be divided by the 38 factorial at the bottom. And the remaining will be the 2 factorial that we get from the N minus R. 2 factorial, we will end up getting 780. Next, here, we will just do 8 factorial over 4 factorial times 4 factorial. And remember, from the 8 factorial, the 4 factorial we can cancel out. We remain with 8 times 7 times 6 times 5, because the 4 factorial has been cancelled out. Divide by the other 4 factorial that's there. 4 times 3 times 2 times 1. And here, these two can cancel out with this. 8 and 4 to 1. We end up with 70 right here. Then N choose 0 is just going to be N factorial over 0 factorial times N minus 0 factorial, which is again N factorial. So here, these two can cancel out. We end up with 1 over 0 factorial. Remember, 0 factorial is just 1 again. So anything that is choose 0 is just going to be 1 as your answer. Finally, N choose 1. Again, we'll have N factorial, which is just equal to N times N minus 1 factorial. Okay? And we're going to divide it by 1 factorial times N minus 1 factorial. Then again, these two can cancel out. We remain with n over 1 factorial, which is just going to equal n. Next, Pascal's triangle can also be calculated using n choose r. Now, what exactly is Pascal's triangle? It's this right here. So we write 1 around the edges. Yep. And then we go like this. 2, 3, 3, 4, 6, 4, and so on. And if you see, it's basically symmetrical, meaning the left side is going to be symmetric to the right side, right? And that's how these combinations work as well. Because if I have 7 choose 5 and I have 7 choose 2, both of these are the exact same. Why? Because both of them are 7 factorial over 5 factorial times 7 minus 5, which is just 2 factorial. This is going to be the same thing, 7 factorial over 2 factorial times 7 minus 2 factorial, which is just 5 factorial. So these are going to be the exact same. With Pascal's triangle, we see we have rows, right? We start from 0, counting them from 0, and we have the 0th row, 1st row, 2nd row, 3rd row, 4th row, and so on. And if you see what we did there, the rows that you have is the number at the top. So you can go up to the nth row and you'll get n at the top. So you'll do n choose something, right? The column gives you the r that you want, right? So let's start off with the first column as the 0th column and the last column as the nth column. So 0th column, this whole thing is the 0th column because it's the first column in each row. Then second column in each row, meaning it's going to be the first, and it's going to be column 1. Then we have column 2. Then we have column 3, column 4, and we can go on up to column n. Remember, we always start from 0. That means our first column will actually be the 0th column, right? Then we should know these because it just makes life a lot easier, okay? So we did this before. Whenever you have n choose 0, we just have 1. Whenever we have n choose 1, we just have n. Then these two are a bit more complicated, but not really. Where, remember, this is just n factorial over 2 factorial times n minus 2 factorial. But we should know that n right here, remember, you can cancel out with the bigger one. N right here is just going to be n times n minus 1. And then we can multiply it by n minus 2 factorial. Because it's still going to go on, right? And these two will then cancel out. We'll end up with n times n minus 1 over 2. So n minus 1 over 2. That's going to be n choose 2. For n choose 3, the same thing we do. Just add one more number. N times n minus 1 times n minus 2 times n minus 3 factorial over 3 factorial times n minus 3 factorial. These are going to cancel out. We end up getting n times n minus 1 times n minus 2 over 3 factorial, which is just 6. So n times n minus 1 times n minus 2 over 6. And that's going to be n choose 3. Then example 2, find an expression in terms of m for n choose 4. We're going to do the same thing here, just add another layer, right? So n times n minus 1 times n minus 2 times n minus 3 times n minus 4 factorial over 4 factorial times n minus 4 factorial. These are going to just cancel out. 4 factorial is 24, and we end up getting n minus 1, n minus 2, n minus 3 over 24. And that's going to be our n choose 4 expression. Next, find in ascending powers of x the first 4 terms in the expansion of these two. Now, whenever you are expanding using this NCR, the general formula that we use is this. So suppose we have an a plus b power n. The way we expand this is we do n choose r of a power n minus r multiplied by b power r. Now, we know what n is, okay? N is just the power that we have on top. A is the first term that we have. B is the second term that we have. What about r? R is what you are the one who decides. in order to get a certain power that you might need. So for example, here you want the first four terms of the expansion in ascending orders. That means you want x power 0, x power 1, x power 2, x power 3. You are supposed to decide what r gives you this. And it's quite easy to decide. If you check this right here, a plus b power n, we will get 15 cr 1 power 15 minus r x power r. And here this tells you exactly what you need for r. When r is 0, we'll get x power 0. R is 1, we'll get x power 1. R is 2, we'll get x power 2. And r is 3, we'll get x power 3. And so we're going to use these r's and put them into this. So we have 15 C0, 1 power 15, x power 0. We'll have 15 C1, 1 power 14, because 15 minus 1, x power 1. And we'll do that for all the four r's. And then we can find the value from this. So we have 15C0, which is just 1 times x power 0, which is also 1. So this gives us 1. 15C1 times 1 power 14 times x. 15C1 is just 15 times 1 times x, which is just 15x. Then here we'll have 15C2, which is just 105. And then times 1 times x squared, so 105 x squared. Then finally we'll have 15C3, which is 455 times 1 times x cubed, which is 455 x cubed. Remember, you can also do this in your calculator, where you can write your n number. So you write your n, then you will click on this sign right here. There's going to be this sign in the calculator, and then you finish off with your r number. So I would write 15, then that sign right there, it's going to give you a c on your display. Then you end up with this number, and you will get your value for your NCRs. Okay, we're going to do the same thing for 2 minus 3x power 10. And again, our r equals 0 will give us x power 0, r equals 1 will get us x power 1, r equals 2 will get us x power 2, and r equals 3 will get us x power 3. And we'll continue with that. And this is what we will get for the first four terms: r equals 0, r equals 1, r equals 2, and r equals 3. Remember, we need to write the entire term. So here you're going to write the entire negative 3x in place of b, and we can just solve this. So 10c0 is 1, 2 power 10 is 1024, and negative 3x power 0 is just 1. So this is just going to be 1024. Then you go and look at the next one. 10c1 is just 10, 2 power 9 is just 512, and negative 3x power 1 is just negative 3x. So we multiply all these together, we get negative 15,360x. Next, we can do this one. So 10c2 is just 45, 2 power 8 is just 256, and negative 3x power 2 is just 9x squared. And we will get 103,680x squared. Finally, we do the last one. 10c3 is 120, 2 power 7 is 128, and negative 3x power 3 is just going to be negative 27x power 3. Multiply them all together and we will get negative 414,720 x power 3. And these are going to be our first four terms of that expansion right there. We can also write them in plus format, right? So we'll do 1 plus 15x plus 105x plus 455x cubed. Or for here, 1024 minus 15360 plus 103680x squared minus 414720x cubed. For the next example, we're looking at 1 minus x over 3 power n is expanded in ascending powers of x. So again, x power 0, x power 1, and so on. And the coefficient of x squared is 4. Given that n is a positive integer, find the value of n. So firstly, let's just write this generally how it would look like. N, C, R. Then the first term, which is 1 power n minus r. Then the second term, which is negative x over 3 power r. Then we want when the power of x is x squared, right? For that, we will need our r to be 2, as we can see here. If we have our r as 2, then x power 2 will just give us x squared. So we want to find specifically for when r equals 2. So n, c2, 1 power n minus 2, and negative x over 3 power 2. nc2 is going to be written how? We did this previously. where it's going to be n times n minus 1 over 2. Multiply that by 1 here, then multiply that by x squared over 9, and we want it to be 4x squared, right? You want the coefficient of x squared to be 4. Obviously, x squared and x squared we can cancel out, so we just work with the coefficients, and then we can do it from there. So we have n minus 1 over 18 equals 4. Multiply 4 on both sides, we end up getting n minus 1 equals 72. Then we can expand this and use this as a quadratic equation, right? So n squared minus n minus 72 equals 0. And we can solve this right here. We will get n equals 9 or n equals negative 8. And remember they said that n is a positive integer, therefore n is going to be equal to 9. And so we reverse engineered to get our power n from the coefficient of one of the terms. Next, when 2 plus kx power 8 is expanded, the coefficient of x power 5 is 2 times the coefficient of x power 4. Given that k is greater than 0, find the value of k. So again, we want to look at the x power 5 term and the x power 4 term. Yeah, and for that, let's just write that first, the general formula. So 8cr, the first term power 8 minus r, and the second term power r. And we want x power 5, so we want r to be 5 in our first one, and we want x power 4, so we want r to be 4 as well. Then we'll compare these two. So when r equals 5, it's going to be 8c5, 2 power 8 minus 5, which is 2 power 3. And then we have kx power 5. And for the second one, we have 8c4, 2 power 8 minus 4, which is 4, and kx power 4. For the first one, we get 448 k power 5 x power 5. For the second one, we get 1120 k power 4 x power 4. Then we compare the two, where we know that the coefficient of x power 5 is 2 times the coefficient of x power 4. So 448 k power 5 equals to 2 times 1120 k power 4. We can open the brackets here, so 448 k power 5 equals to 2240 k power 4. And we want to solve this, solve value for k. We can take this to the other side. We end up getting 448 k power 5 minus 2240 k power 4 equals 0. Then what we can do here to solve this is a hard one because it's something we haven't seen before. So what we can do is just factorize k power 4, 448k minus 2240 equals 0. Then what you're solving is this thing right here. So either k power 4 equals 0, not possible because it said k is greater than 0. So we'll do 448k is equal to 2240 divided by 448 divided by 448. We get a value of k to be 5. And that's going to be a value of k for when the coefficient of x power 5 is 2 times the coefficient of x power 4. Finally, example 6. We're told to get the first 3 terms in the expansion of 2 minus x times 1 plus 2x power 9. So for this, firstly, we need to find the terms here. Then what we would do is multiply it with this bracket right here. So we're going to do that here. So let's write the general formula first. 9cr, 1 power 9 minus r, and 2x power r. Then we want the first 3 terms, and so what we will do, we will make r equals 0 to get x power 0 right here. We will make r equals 1 to get x power 1. And we'll make r equals 2 to get x power 2. And those are going to be the first 3 terms right here. So we're going to do that. 9c0, 1 power 9, 2x power 0, 9c1, 1 power 8, 2x power 1, and 9c2, 1 power 7, 2x power 2. And up we are going to get, here we're going to get 1 times 1 times 1, so we're going to get 1. Here we're going to get 9 times 1 times 2x, we're going to get 18x. And here we're going to get 36 times 1 times 4, which is going to be 144x squared. And so with this expansion right here, we have 1 plus 18x plus 144x squared. And we're going to multiply that by 2 minus x. Expanding this, we want to multiply everything by 2. So 2 plus 36x plus 288x squared. And multiply everything by negative x. So negative x minus 18x squared minus 144x cubed. We're not going to use this right here because they asked for the first 3 terms. So we're going to remove this and we're going to deal with whatever we have here. So it's going to end up being 2 plus 35x plus 270x squared. And that's going to be the first three terms of this expansion right here. Then they tell us to use the answer to part A, which is this right here, to estimate the value of this. Now if you see this, it's exactly a carbon copy of this, just that now we have a value of x. And that value of x we can find because 1 plus 2x equals to 1.02 and also 2 minus x equals to 1.99. And both of these give us that x equals to 0.01. And if we use this x equals to 0.01 and we put it in terms of x, remember these are the first three terms. The reason why this is a good estimate, because the terms after that are going to be x cubed, x power 4 and so on. And if you put in 0.01 into these values, you're going to get a very, very small value, which is not going to make a significant difference to your answer. That's why these three terms are a good estimate, because these are the largest values that you will get out of putting x as 0.01. So that's what we will do here. We'll get 2 plus 0.35 plus 0.027. And this is going to give us 2.377 as our answer. So this is going to be our estimate for the value of this multiplication right here.